So today we are closing out Unit 2. So things you need to remember, the types of solutions an equation has. You have those equations where you end in some variable equals some number. You have a variable equals a number. Then this is the only number that I can plug back into the equation. Let's say I solved for x in this equation, 2x plus 2. Then this is the only number, this 2 is the only number I can plug back into this equation to equal 6. So what I mean is, there's no other number, there's only one number that I can plug back into this equation. So I can plug 2 in, and yes, it will equal 6. But if I use another number, let's say I have 3, it's going to be 6 plus 4, or 10. So this is not equal. This is not a solution. However, 2 is that only number. Now, that's one solution. But let's say I had infinite solutions. Then that's when I create a situation where when I'm solving, I get 2x plus 6 equals some other quantity, but it's the same quantity. Let's say I end in 2x plus 6 equals 2x plus 6. Here, this is a situation of infinite solutions. And essentially, I could pick any number, not even essentially. I could pick any number just automatically, just because, and plug in each side, and it will equal the same thing on both sides. So how would I get there? Where would I start? You'd probably start with a situation like this. And you have 2x plus 6 on one side equals 2 times the quantity of x plus 3. When you're solving for this, you end up with this on both sides. And it creates a situation where you can plug any number in. Let's say 3. If I want to say 2 times 3 plus 6 equals 2 times 3 plus 6. If I solve this on both sides, I have 6 plus 6 over here, and I get 12. And we find that you get the same things on both sides as you go through each step. This is a case of infinite solutions. You can plug any number, replace that x, and get the same thing on both sides. Now, no solutions. This is a situation where you have two variable quantities, let's say 2x and 2x on both sides, but they change it up with these constants. Let's say we have plus 5 over here, but then we come around and say plus 1 on this side. So these constants, the uniqueness of this situation is that both of these are the same, but those constants literally throw everything off. You're going to have 5 more on the other side, no matter what. If I plug a 1 in here, I would get 2 plus 5 is 7. And then if I plug a 1 into the other side, I'm going to get 2 times 1 is 2. 2 plus 1 is 3. So 7 does not equal 3. So for instance, just not to be so abstract, 2 times 3 plus 5 over here, and I get 6 for right there. Over here, I say 2 times 3 plus 1, and I get 2, for 2 times 3, I get 6. Now, so far, they're equal. But like I said before, you get the 5 more on the left and the 1 more on the right, creating a situation of uneven numbers. So it's not equal. This is how you create no solutions. All right. What else is important in this unit? Other things that are important, properties of real numbers. And I won't go through those because that's a lesson within itself, but definitely have those properties out while you're working through this lesson. So going back to where we're supposed to be, it's Unit 2. So for the first part, it says solve each equation, show all the work, and if your answer is something other than one solution, state whether there are infinitely many solutions or no real solutions. So the first problem is fairly simple. This just says negative 5 times x equals 20. Divide both sides by negative 5. We find that x equals negative 4. This is one real solution. Okay? Next part, we have 6x's plus 5 equals 21, minus 5 on both sides of the equal sign. 6x comes down, this goes away, equals 16. Divide both sides by 6. This reduces to x equals 8 over 3. And there is exactly one solution. Number 3, you're going to distribute first. So 4 times x is 4x. And 4 times negative 2 is negative 8 equals negative 20. You add 8 on both sides. You get 4x coming down, that part going away, equaling negative 12. You divide both sides by 4, and x equals 3. So make sure you're circling your answers and writing the number of solutions. And remember, when you get a variable equals a number, you're getting a one solution type of result. Number 4. Circle by like terms. I have 9x's and negative 6x's, and I get 3x. And so those go away. 5 minus 7 is negative 2 equals 34. Okay? Now, add 2 to both sides. 3x's comes down equals 36. Divide both sides by 3. And x equals 12. One solution situation. Number 5. If you're struggling with fractions, we're just going to take the numerator, and multiply it by 6. So if I rearranged, I would have 5 times 6 divided by 3 times x minus 11 equals 19. Get 30 divided by 3, or 10x's, minus 11 equals 19. Add 11 to both sides. I get 10x equals 30. Now you divide both sides by 10, and x ends up equaling 3. And there is one solution. One solution. Okay. Number 6. We're going to distribute first, so we don't touch the 6, it just comes down. When I distribute, though, I have plus 2 times 4, which is plus 8, and then positive 2 times negative x is negative 2x, equals 7 minus 9x's. Combine my like terms, 6 and 8, and I get 14 minus 2x's equals 7 minus 9x. Now, I'm going to add my variable term to both sides. Get 14 coming down. This goes away, equals 7 minus 7x's, minus 7 on both sides. I get 7 equals negative 7x's. Divide by negative 7 on both sides, or that coefficient of x, and I get x equals negative 1 one solution situation. Now, at this point of the review, I'm not going to do 7, 8, and 9. I expect you to be able to do those on your own. I will tell you that number 9 is a no solution situation. Number 7, you're going to be combining like terms on the left, distributing on the right, and then moving with those steps that you already know how to do. Number 8, you're going to distribute on the left, distribute on the right, and then move forward with those steps of moving your variable terms and your number terms, and then dividing by a coefficient of x. And number 9, I would look very closely at the situation that you have and look back at the very first part where I talked about no solutions. Number 10, we did a similar problem like this already in the classwork. You're going to be reading through this problem. I would circle the formula or the literal equation, and I would replace the variable that I need to replace. Number 11, think about money that this person is spending, and think about what per means, like what operation it is, adding, subtracting, multiplying, or dividing, and set up an equation. Solve for the number of hours. Number 12, we will just look at this, number 12, so I can make sure that you understand how to approach these problems. Now, when you're choosing from properties below, from these properties in this table, there's 6 properties. You just have to recall what they look like. So the associative property, it's that situation where you have parentheses and you're adding 2 things first on one side, and then you change up what you're adding on the left. So you kind of slide parentheses to create a situation of association. Now, the addition property of equality is where you add something on both sides of an equation of the equal sign. Distributive property is where you have the situation where you're multiplying times the added quantity, and you multiply this factor outside a twice, first by a by b and then by c to create ab plus ac. The division property is where you're dividing on both sides. Commutative property, you're creating a situation where no matter what order you add 2 things or even multiply 2 things, you always end up with the same situation, or the same thing. The transitive property, this is where you cut out the middleman. Let's say I have 1 equals x, and x equals 2 divided by 2. Then you cut out the middle part, and you create a conclusion of 1 equals 2 divided by 2. You take the ends, and that's all you're left with. Okay? So in order to do these problems, you look at either the step itself or the previous step and go to the next step and see what changed. So just a good example will show you what I mean. It says, which property justifies step 1? So I'm going to look at what has changed. If anything has changed, or if I'm doing something to step 1. I'm not doing anything to step 1, but something has been done to get to step 1. So looking at what has not changed, 6x hasn't changed, but what has changed is this has gone away and it became something new. So you pick from the properties to see what describes the change that's occurring. So looking at this, it looks like they distributed. The indicators are that there's a factor out front, and you're multiplying that factor by 2 things added inside, and it looks a lot like this situation. So this is the distributive property. So for the next problem, same thing. You want to check, has something changed or is something occurring in the step itself? So what property justifies step 2? From step 1 to step 2, they did change something. So let's look at what they changed. Let's look at what they didn't change and what they did change. Tens, the tens didn't change. They didn't change. Now, the 12s didn't change either. 12s didn't change either. But what has changed is they flipped the order of things that they were putting together. So they flipped the order, and it looks a lot like the commutative property where they flip the order of things. So here, the commutative property justifies the change from step 1 to step 2. Step 3, either something has changed or, sorry about that, or something has changed or they're doing something in that step. So what they're doing in the step that justifies what happened is they're adding 8 on both sides. This is the addition property. It's a good example of the addition property of equality. Step 4, they're dividing 18 on both sides. This is a good example of the division property of equality. So, next part, says given the equation 3x plus 8 equals 29, we choose to get rid of the 8 first. So they're solving for it. What property are they doing if they're getting rid of the 8? They're going to get rid of the 8. They're going to use the inverse or the opposite of positive 8 and subtract 8. Okay? Using the transitive property, fill in the blank. If 2x plus 3 equals x minus 1, and x minus 1 equals 4x plus 8, then 2x plus 3 equals, think about what you're looking at. You have 2x's plus 3, and x minus 1. Oh, sorry. Arranging that wrong. So 2x plus 3. So if 2x plus 3 equals x minus 1, and x minus 1 equals 4x plus 8, they want to know what they can conclude about 2x plus 3. This is your transitive property, so you cut out the middleman. You're left with the tail ends. 2x plus 3 equals 4x plus 8. Final answer. Okay? So next one, last 3. I'm going to solve literal equations. Number 1 is special case. It's a special case because you're going to be reverse distributing, okay, to solve for g. So we have fx, actually not this one, it's a different one, equals fx minus gx equals h. Solving for that g term, so I'm going to subtract fx on both sides. They go away. Negative gx comes down, equals h minus fx. Now, I want to get rid of the x and negative, so I'm going to divide by those things for each term. We don't do both terms. And the x's go away, the negatives go away. I'm left with g equals negative, bring that negative up, x, h over x, minus x's go away, minuses go away, and becomes plus f. And I circle my answer. Number 2, I'm solving for x, so this is where we're going to reverse distribute. So the reason we can is because we have an x in both terms. So basically, we bring an x out, and we divide x out of each term. What we're left with is x times the quantity of g, these x's go away, plus those x's go away, 1, equals r. Now I'm solving for x, so I'm going to get rid of the thing I don't need, which is g plus 1 on both sides. This goes away, x equals r divided by g plus 1. And I circle my answers. Number 3, we're solving for n. We have G equals X plus N divided by P. Recall when I said you want to get rid of a fraction or you want to get rid of a number on the bottom of a fraction, you multiply by it. You get PG equals X minus N because X plus N because the P's cancel. Now you're solving for N, so you're going to get rid of the X on both sides. You know these are not like terms, so they just come down on side of each other. We write them side by side, and your N comes down. And your final answer is PG minus X equals N. That's all of the Unit 2 review. Hope you have a good day. See you in class.